All right, here we go. So problem 26. We've got these three crates over here, right? Mass 1, mass 2, and mass 3. And we're actually given the masses. So our mass 1 is 30 kilograms. Our mass 2 is 10 kilograms. Our mass 3 is 20 kilograms. All right, let's let M, just M by itself, represent the mass of the system. So that would be all of them added up. So in this case, 60 kilograms, right? So it's M1 plus M2 plus M3. All right, so I'm going to give that a name. All right, and then we're told that it's being pushed by this external force, F, that's 440 newtons. All right, and then it tells us that the coefficient of kinetic friction is 0.7, and it wants us to find the magnitude of the force of crate 3 pushing backwards on crate 2. Okay, so that's sort of our goal. All right, so question A asks us to use these numbers and find it. Question B says, what if the coefficient of friction is less than 0.7? What would that force be? All right, so here's what I'm going to do. I'm actually going to solve this just using letters. Let's pretend we didn't know any of these numbers. All right, and let's see if we can come up with an expression to find the force on crate 3 from crate 2 in terms of not these numbers, but these variables. Okay, so those are the variables I've got at my disposal. The individual masses, and then M is going to represent all of the masses added up, the mass of the system. All right, so here's how this is going to work. So you always start when you're looking at a system of objects. I shouldn't say always, but usually you start by looking at the system as a whole, particularly if you don't know the acceleration. All right, so let's do this. So let's look at the system. So our system has a mass of M. Remember, that's just M1, M2, and M3 added up, right? So what forces are on it? Well, there's our applied force of F. There's going to be gravity, which is mg. There's going to be a normal force, which is just going to cancel out that force of gravity, right? Because there's no other vertical forces. And there's going to be a force of kinetic friction. Now, the coefficient of kinetic friction between all the boxes is the same, so we can kind of treat it as one big box with one coefficient of friction. So our force of kinetic friction is going to be the force of kinetic friction is going to be the coefficient of kinetic friction times our normal force. So that's just mu k times mg, right? So that's the free body diagram for my system, right? So that means that the acceleration of the system is just net force of the system divided by m, the mass of the system, right? Kind of wish I'd used m cis, but whatever. Okay, so our net force then is just going to be F minus mu k mg, right? F minus mu k mg all over the mass, right? Okay, so there is what's happening with the system. Okay, so now what we want to do, now that we know our acceleration, and I guess I should comment at this point that clearly there's no reason why we couldn't take these numbers over here and plug them in and find out what this actual acceleration is. If you do that, for this example, the acceleration of the system ends up being, if you're keeping score, 0.473 meters per second squared if you use the numbers. So that gives you the acceleration of the system. Okay. Now, so now let's do this. We're trying to find the force on crate 3 from crate 2. Oh, shoot it. When I drew that before, I drew it wrong. We're trying to find the force on crate 3 from crate 2. So this is the force of crate 2 pushing crate 3. So that's what we're trying to find. All right? So what I'm going to do now is let's just look at crate 3. So crate 3 has got the following forces. So here we go. Its mass is M3. It's being pushed forwards by box number 2, so I guess I'll use the book's notation. That's force on 3 from 2. Okay. Gravity's pulling it down. There's a normal force on box 3, which would just be equal to the gravity. And then there's friction, which would be equal to the coefficient of kinetic friction times the normal force, right? Okay, so here's the deal. I know I'm going to write two different expressions for the net force on this thing, all right? So for crate 3, here's what I know. I know the net force on crate 3 is, well, it's the force on box 3 from 2 minus the coefficient of kinetic friction times mass 3 times g, right? Okay. But I also know that the net force on 3 is equal to the mass of 3 times the acceleration of 3, right? Oh, well, that's equal to the mass of 3 times the acceleration of the system, right? Because the whole system is going to move together, right? And we know that up here, here's the acceleration of the system. So this becomes m3 times f minus mu k times m times g all over m, right? Okay, so what are we trying to do? We're trying to find F32. That's our goal, is to solve for this dude right here, right? So all I'm going to do is I'm going to set this and this equal to each other. Okay, so here we go. All right, so here's what we've got. I've got force 3, the force on 3 from 2 minus mu k times m3 times g is equal to m3 times sorry, I was just double checking my notes here, making sure that I hadn't made any mistakes here. I think we're in good shape. Keep our fingers crossed. A lot of numbers to keep track of. All right. So, but what I'm doing here, this is huge, you guys. This is how a lot of the AP questions are. There aren't numbers, and so I think there's some value in solving them this way. And you know, as you know, this is my first year teaching this. I'm wishing I'd been solving more of the problems this way from the start. Definitely next year I'll make some changes. Okay, so we're almost there. So let's see. So what I'm going to do now, we're trying to solve for F3. So let's multiply or add, add this to both sides. So you get the force on box 3 from box 2 is this. M3 times F minus mu k mg over m plus mu k m3g. All right, so let's see. Let's simplify this. I'm going to distribute this. All right, so my first term that I'm going to get is, let's see, I'm going to get m3 times f over m, right, for the, this first chunk. And then for the second chunk, something cool happens here. So when I distribute, I'm going to get m3 times mu k times g, but the m and the m here in this term are going to cancel out, aren't they? All right? Okay, so plus mu k times m3 times g, and you notice, holy cats, this thing and this thing are the same, right? I've got them written in different orders, but they're the same thing, right? So here's my answer, right? So that means that the force applied to block 3 by block 2 is just equal to the ratio between the mass of block 3 and the mass of the system times F. And it doesn't depend on the coefficient of kinetic friction. Okay? So for us, the mass of block 3 was, what was the mass of block 3? It's written up here at the top. Mass of block 3 was 20 kilograms. So 20 over 60 times the applied force was 440 newtons. So multiply all of that out and you get 147 newtons. All right. So there you go. Whole bunch of algebra. All right.